Hello everyone, welcome back to lesson 11. In this lesson we are going to explain composition function or composition of functions. This means we mix two functions or more. Operations on functions are just like operations on numbers. We can add functions, we can subtract functions, we can multiply functions, we can divide, and most importantly, we can have f of gx or g of fx. Now, let's have some of these practically. fx is 2x minus 3. Gx is x squared plus 1. Okay, we have fx equal to 2x minus 3 and gx equal to x squared plus 1. Let's check. 2x minus 3, x squared plus 1. Okay. Now, if I want to find f plus gx, there are many ways of writing this. We can put brackets here. It's fine. We can write it without brackets. It's also okay. Here, all you have to do, add f and g together. To add f and g, we add these parts together, so it will be 2x minus 3 plus x squared plus 1. When we add algebraic terms like this, we add the like terms together. X squared is alone, that's x squared. X is also alone, that's positive, so I write plus 2x. Negative 3, positive 1 is negative 2. This is f plus gx. Now, if I want to do f minus gx, fx is 2x minus 3, and gx is x squared plus 1. If I want to do f minus gx, this means fx minus gx. Then fx is this, 2x minus 3, minus, for the g, remember, this minus is for the entire g. It's better always to put bracket, x squared plus 1. Now, to simplify this, multiply this negative by inside the bracket. It will be 2x minus 3 minus x squared minus 1. Again, x squared is alone. It will be negative x squared plus 2x, negative 3, negative 1 is negative 4. So this is the result of f minus gx. We can also have g minus fx. G minus fx. This time we write g first, minus bracket fx. It's going to be like x squared plus 1 minus 2x minus 3. Now, the first step is to expand the bracket. This minus multiplied by inside. This is going to be x squared plus 1, as they are, minus 2x, minus minus plus. This is where most of the students make mistake. When you say minus f, this minus is for the entire f function. And when it's for the whole function, we should multiply it by each single term. And negative times negative is always positive. We all know minus minus plus, but where? Here, in multiplication. Now, x squared has no partner to be added with. 1, 3 is 4, minus 2x plus 4. So this is the result of g minus fx. These are simple. What if we have g times fx? Raising this. This time we're going to do g times fx. G times fx. Sometimes there's a little dot between them. The dot is still multiplication. Later we will see how can we find f of g. This is the most important one. Here, f g times f. This is different from f o g. Without this o, or without enough space between f and g, it's not composition. This is multiplication. I'm going to multiply g by f, and for these subjects, it's better to keep the order. It's better to write g first, x squared plus 1. I multiply g completely by f. F is 2x minus 3. Now, to do this, I multiply the x squared by both terms, then multiply 1 by both terms. Then if we had like terms, we add them together. Now x squared times 2x, it will be 2x cubed. Okay. X squared times negative 3 is negative 3x squared. One quick way to check your answer is like, this bracket has 2 terms, this bracket has 2 terms. At the end, I will have 4 terms. Then I'll simplify. Now x squared, complete. 1. 1 times 2x is 2x. This minus plus, it's not random. It's because of the result. Here, x squared times 2x, they are both positive. The result is also positive. X squared times negative 3 makes the result negative 3x squared. This is why I write minus here. I don't write plus or minus randomly. Then positive 1 times 2x is positive 2x. This is why I write plus. Now 1 times negative 3 is negative 3. So I should write minus. Now, as you see, there is no any like term. There is x power 3, x power 2, x, and number. There is no like terms to be added with. So this is the final answer of gfx. Now if we do fgx, fgx, the result will be the same because multiplication is commutative. F times g is the same as g times f. Then we're going to get the same answer. Most importantly, FOG. The division, we just write them like this. F over g is 2x minus 3 over x squared plus 1. As you see here. If there is simplification, we do simplify. If there is no simplification, we keep it like this. For f of g and g of f, let's do them. Okay, again, fx is 2x minus 3, gx is x squared plus 1. Now if I want to find f of gx, it's fine to not write bracket, it's okay to put bracket around them, they're both fine. F circle g or f of g, this means put the function gx back into f. This means put the function g completely in function f. Where can we put something in function f? In place of x. Then we can rewrite this as f of gx. Means gx goes in function f. Gx goes in function f where? In place of x. So the result will be like 2. Instead of x in f, I write the function gx completely, which is x squared plus 1. Then minus 3. This is the function gx inside f. There is simplification. Multiply this 2 by inside. It will be 2x squared. 2 times 1 plus 2 minus 3. Plus 2 minus 3 will be negative 1, so the result is 2x squared minus 1. See? This is f of gx. Now, if I want to find g of fx, most of the time they are not equal, f of g and g of f. And in some cases they are equal. So we should find it. We cannot decide if they are equal or no unless we find it. Now I'll write g of fx. This means put f in g. So I'm going to write like this. G of fx means put the function fx completely into function g in place of x. This time I'm going to write 2x minus 3 in place of this x. Then it's going to be like this. G is x squared. Instead of x, I have 2x minus 3 squared plus 1. To expand this bracket, there are two ways. The first way is to write the bracket twice and manually multiply all the terms by each other. The second way is to follow the note that I told you in the previous classes. Term 1 squared, 2x squared will be 4x squared. 2x times negative 3 is negative 6x, times 2 is negative 12x. And second term squared, negative 3 squared is positive 9 plus 1. This is going to be 4x squared minus 12x plus 10. This is the result of g of f. Now let's go back to the book. Here. 4x squared minus 12x plus 10. We got all the answers. These are the notes about what I said. F, O, G, and G of f, most of the time they are not equal, but there are cases that they are equal. They are not always equal. Okay, example. Find the domain of the function where fx is equal to x squared minus 1 and gx is equal to square root of x. Then, firstly, we need to find g of f. Find g of f. G of f means put function f completely in g in place of x. This is going to be like function f is x squared minus 1, x squared minus 1. I'm going to put function f in g in place of x. This is going to be square root x squared minus 1. Now, the graph will be two pieces because the x squared under the root is positive. The graph will be two pieces. Then to find the two pieces, we solve this. X squared minus 1 equal to 0, and 1 goes to the other side, like x squared equal to 1. Square root both sides, so it will be positive, negative, then positive, negative x equal to 1. X is either 1 or x is equal to negative 1. After we find 1, negative 1, we put them on a number line. On both sides, we go outwards. Negative 1 go until negative infinity, and 1 goes up to positive infinity. This is the domain, and we had this case when x squared under root is positive. Let's have another example. Find the domain of the function g of f. G of f means put f in g. Then let's do it. G of f is like this. G of f means f goes into function g. What is f? F is x squared minus 1. F goes in g means f goes in place of this x. That is 1 over x squared minus 1. Then it is a fraction. To find domain of a fraction, we take what's in the denominator equal to 0, like this, x squared minus 1, equal to 0. Solve this. X is either 1 or negative 1, just like the previous example. Then it is a fraction. For fractions, we avoid these numbers. These numbers will cause trouble for the function because they make the denominator 0. We should avoid them. To avoid them, we say domain is all real numbers except negative 1 and 1. This is the domain. This is exercise 28 from the book. Find f of g and g of f where fx is x squared and gx is square root x or radical x. Are f of g and g of f equal? We don't know because they are not always equal. We should find it. To find it, firstly we have f of g. This means put the function g in f. Put the function g in f means f of gx. F of gx means the function gx, which is square root x, we put this in place of x in f. The x in f is power 2. Then this part, which is square root x, will get power 2. And square root and power 2, they cancel each other. The result is just x. This is it. To find g of f. G of f means put fx in g. It's better to write like this to guide you, to not confuse. Then fx is this. This time I'm going to write x squared in place of x in function g. It is going to be like this. And again, root and power 2. Cancel each other. The result is x. If we compare the two results, the results are equal. This means f of g is equal to g of f. Then in this case, they are equal. Question 29. Find f of g and find g of f. Again, compare to see if they are equal or no. Fx this time is 1 over x and gx is x plus 2. Okay. To find f of g means put g in f. Put g in f means put the function g all in place of x in the function f. This g goes in place of x in f. It's going to look like this. If we wanted to find domain, then we take this denominator, x plus 2. This question didn't ask for domain, but if we want to find x plus 2 greater than 0. Why we don't take the equal? Because it's fraction. 0 causes trouble. Then we only consider this, the case of x plus 2 greater than 0. Then domain will be x greater than minus 2. Okay, the question didn't ask for it, then we don't do it. We follow the question's instructions. This time we need to find g of f. G of f means put the function f completely in place of x in g. This time in this part I'm going to put function f, which is 1 over x, in place of x in g. That looks like square root 1 over x in place of x plus 2. Then are they equal? Obviously they are not equal. This question is very important, indeed very easy. Look at this. We have a diagram. The diagram shows the graph of function f. This is f. And this graph below is g. Now, let's answer these questions. Part A says find f of g3. F of g3 is the easy case. This time, we only have to find g of 3. What is g of 3? We don't have function to put g in place of x, but we have graph. Where is 3 on x-axis? 3 is here. Okay, if we look at the graph of g in front of 3, the result of it, which is y, is -1. Then g of 3 is -1. And instead of g of 3, I have -1. Now, I have f and -1 remaining. This means f of -1. F of -1, again, going back to the graph, -1 is here. -1 going towards the function f, the result is 4. This means f of -1 is equal to 4. This 4 is the final result. This 4 is telling us this f of g3 is equal to 4. Now, b. b, it's again composition of two functions, but the way it's written, it's like the step after this. The form doesn't have the little circle between f and g. It is okay. This is telling us the function f is in g, but the f is not f of x. If there's a number, it's the easy case. We don't need a lot of work. We just need to find f of 2, then put the result in g. F of 2, according to this graph, 2 is here. The upper graph is for f, then f of 2 is 1. F of 2 is 1. This part is 1. Now I have g of 1. G of 1, according to this graph, where is 1? Clean this up. Where is 1? 1 is here. Okay. I want g of 1. G of 1 means I need to use this graph. This is the graph of g. So, result is -2. -2 is the result. Then this answer is -2. G of f of 2 is equal to -2. And you saw the steps. Part C, G of f of 5. Find f of 5, put the result in G. F of 5. 5 on x-axis is right here. Then f of 5, this graph is for f. F of 5, we should go to this point. Then the result is -5. This f of 5 is -5. Now I have g of -5. Okay. If I go to -5 on the graph, -5 is right here. Okay? Look at -5. I don't have any graph of g at -5. This means I cannot find the value of g of -5. This means, according to this diagram, g of -5 does not exist, or it's undefined. D, f of g for -3. F of g -3, we should find g of -3 first. According to the graph, g of -3, this is -3, g of -3 is -2. Then result is -2. This g of -3 is -2. Okay. If g of -3 is -2, and I have the f left, I should find f of -2. F of -2, according to this graph, f of -2, -2 is here, f of -2 is equal to 3. Then f of -2 is 3. This 3 is the result of this part. It's equal to 3. E, f, g of f, -1. Then f of -1, according to the graph, it's 4. G of 4 is 2. Then the result is 2. Finally, part F, f of g -1. G -1 is -4. F of -4. At -4, I don't have any graph of g, and I don't have any graph of f. G of -1, g of -1 is equal to -4 according to the graph of g, and f of -4 at -4, I don't have any graph of f. This means I cannot find the value of f of -4. Then f of -4, according to this diagram, does not exist, or it's undefined. Got the results. Then let's move to the next question. Here, this one is also a good question. Previously we learned about transformations, how plus, minus, from inside the functions affect the graph, how plus minus from outside the function affect the graph, and how multiplication affects the graph. Multiplication, if you multiply a function by 2, this makes the graph twice wider. And 1 over 2 makes the graph shrink, so the graph will be half size. Now look at this. The given graph is for f. If we have then f of x minus 4, we said minus 4 drags the graph 4 units to the right, because the minus 4 is inside, so it's opposite. The graph is here. Zoom this out. This red graph is the original graph of f. Then minus 4 means move the graph 4 units to the right. Then if we move it 4 units to the right, it's good for such questions to focus on one point. It's good to focus on 1 or 2 points. This point is a good point to focus on. This point is to 1. If I move this point 4 units to the right, only the x value changes. There is no vertical change. The y, which is 1, stays as 1. Then the 2 plus 4 becomes 6. This is why this corner, which was at 2, now it's at 6, 1. This blue graph is the answer of part A. Part B, similarly, if we look at this point is negative 4, negative 3. Then the point negative 4, negative 3, similarly, it's been moved 4 units to the right for part A. Now part B, it is f of x plus 2. F of x plus 2 moves the graph 2 units to the left. Then this red graph should go 2 units to the left, then it will be the graph of part B. We can see it. That's here. No, part B is not here. Let's do it then. Part B, let's use a black pen to make the colors different. This point is 2, 1. If I want to move this graph 2 units to the left, because of this plus 2, I know it goes 2 units to the left. Then this point, if I move it 2 units to the left, it's 1, 2. This point will be this one. It goes 2 units to the left because of this 2. And this one goes 2 units to the left, it will be here. Now, joining these two, and the horizontal parts stay the same because this translation is horizontal. Vertically, there is no change. There is no change on y. The change is only on x. Okay? Now, part C. This black graph is the answer of B. C is f of x as it is plus 4. This plus 4 will raise the graph 4 units up. This plus outside will raise the graph 4 units up. Again, we focus on one good point. Here, this point, I don't know the coordinates exactly. Don't estimate this as 0.5. It's not 0.5. We don't know. It could be any number between negative 1 and 0. Focus on a coordinate, focus on a point that has good coordinates. Like the first point I marked. This point is a good point to focus on. It's to 1. Then if I want to move this point 4 units up, then it goes like 1, 2, 3, 4. This means this corner, this joint will go there. Similarly, this joint will go up 4 units, goes there, then only joining them and complete the horizontal sides. Part D. D, again, is vertical motion. It is f of x as it is minus 1. This will lower the graph by 1 unit. This green graph is the answer of part D. If we look at the point, it went down by 1 unit. Similarly here, then joining them will make the graph. Okay, part E. It's 2 times fx. 2 times fx will stretch the graph and makes the graph twice taller. Now it changes the height. This height, which is from the lowest point to the highest point, when we multiply fx by 2, it will be doubled. When we multiply fx by 2, fx is y, then it's going to look like this. Again, the point 2, 1. Every point, the first number is x, the second number is y. Since here the change is on y, it's 2 times fx means 2y. We only double this y, multiply by 2. The point 1, 2 becomes 2, 2. It will be this point. This point, which is at -4, -3. If we multiply the y by 2, it will be -4, -6. So the point will go down, and then joining them will make a graph that is twice as tall as this graph. We can see it in the next diagram. Here, part E, we had the point. This red graph is the default one. It's the graph of f. Then, look at this. This red is the graph of function f. Then this point is 2, 1. When we have 2fx, we always say fx is y. 2fx means 2y. 2y means we only multiply the y value of the point by 2. Then the y value of the point is 1. If we multiply it by 2, it will be 2. The 2, which is the x value, it stays the same. Then this corner will rise up to this corner. It's going to be 2, 2. Similarly, this corner, which is at -4, -3, -4, -3. When we have 2fx, even the y of this point will be multiplied by 2. So it is -3, it's going to be -6. Now look at the blue graph and look at the red graph. The blue graph is twice higher than the red graph. This is because of 2 times fx. Now, for the same idea, if we multiply by a number that's less than 1, 1/2 times fx, this is part f. This makes the graph shrink, and the height will be half of the original height. The original height is like this red diagram. This point is 2, 1. If we multiply by 1/2, the 1/2 goes to y again. This time we have 1/2y. The y value of the point will be multiplied by 1/2. This makes 1 to be 0.5. Then the point 2, 1 became 2, 0.5. The 1 became half because it's multiplied by 1/2. And similarly, this point 4, -3, -4, -3 is going to be -4 and -1.5. The change is only on the y value. Then the graph changes vertically, not horizontally. Okay, this is a good question. A pebble is dropped into a still pond. There's a pond of water. The water is still. Then a pebble drops down. It forms some sort of circles. And the circles are like one after another. Okay. A function is given representing the radius of the circles, because A, which is area pi r squared. The function asks for find A of r of t. This means put the function r in place of this r, then the only variable will be t. After that, look, there's full stop. Everything has meaning. Find A of r of t, full stop. Do this first. Then, what is the area of the outer circle? This is the outer circle, the last circle, after 6 seconds. Okay, firstly, in order to do A of r of t, this means we are going to put this value of r in place of this r. So instead of pi r squared, I want to write pi 0.6 t squared. Pi 0.6 t squared. 0.6 t all squared is going to be this number squared and the t squared, which is 0.36 t squared. 0.36 t squared is right here. This is the function a of r of t. Now when t is equal to 6, which is the second part of the function, when t is equal to 6, we only replace this t with 6. Then we have a calculation like 0.36 pi times 6 squared. Calculator is always allowed in grade 12. Use calculator, do the calculation. You can find pi on calculator by pressing shift, then press the x10 button, then do the multiplication. You will see the answer at the end is 40.7 and a lot of other decimals. Nearly it's 41. The question is in feet. Then the answer will be in feet squared. The question is in feet, not in centimeters or meters. It's feet. Then the final answer, since it's area, we write feet squared. This table question, before, in the beginning, in lesson 2 or 3, I think, we solved a question like this. Now we have this idea. Let's do this. In exercises 40 to 43, match the data with a function from the following list, f, g, h, and k of x. Determine the value of c in each case. Okay. Firstly, we have gx, x squared. Then g of x, by putting some of these values in the functions, we can guess which table belongs to which function. Then we can find the value of c. Okay, here, if I put 1 in place of x in g, if I put 1, g of 1, g of 1 is, according to this, is equal to c times 1 squared, which is c. G of 1 is equal to c. Then here in this table, 1 g of 1, if this table belongs to g, then g of 1 is negative 2. This means c is negative 2. If c is negative 2, let's see if this negative 2 works for the other value of g. If a number is satisfied for 3 values, then it's correct. We don't need to test all the 5 values. Look at here. If c is negative 2 for g, let's see, when I put 4 in place of x, will I get negative 32? Let's see. Okay, g of 4. G of 4 is equal to, I said c is negative 2, so let's put negative 2 in place of c, and then x squared means 4 squared. 4 squared, 16. 16 times negative 2 is negative 32. This is the only 32 in the list, the only negative 32. Then question 40 belongs to g, and the value of c is negative 2. Question 41. Now g, gone. Question 41. When x is equal to 1, 1 is the easiest number to check. When x is 1, let's put 1 in place of x in f. If we put 1 here, let's see how h doesn't work for this table. Here, if I put 1 in place of x in h, h of 1 is equal to c times absolute value 1. Absolute value of 1 is equal to 1. Square root of 1 is equal to 1. Times c, result is c. This means h of 1 is the value of c. If, let's say, this function, if this table belongs to h, then c will be 1 over 4. Now I need to test this c to see if it's correct. I'm going to put 4 in place of x this time, still in function h. H of 4 is equal to, I said c is 1 over 4, multiply by square root 4. Now, absolute value of 4 is 4. Square root of 4 is 2. 2 times 1 over 4. 2 times 1 over 4 is 2 over 4, which is 1 over 2. Do I have 1 over 2 here? No. This means this table doesn't belong to function h. Then let's try another function for this table. But I still know that h of 1 is c. Okay? This information is useful. Whichever table belongs to h means h of 1 is the value of the c. Now, this is telling me 1 over 4 didn't work for this table. Then this means this table doesn't belong to h. Let's try another function for this table. The other function I have is f. Okay, in f of x, if I put 1, f of 1 is equal to c times 1, which is equal to c. F of 1 is c. Then if c is 1 over 4, now let me test this 1 over 4 for another value in the table. Now when x is 4, f of 4, according to what I know, is equal to c times 4. c is 1 over 4 times 4. 1 over 4 times 4 is equal to 1. Then this one is true. This is telling me this table belongs to f, and the value of c is 1 over 4. Now, this table. Obviously, this table belongs to a fraction because at 0 it has problem. It has no value. The only fraction in the list is k. c over x. c over x, when x is 0, it will be c over 0. c over 0 is undefined. Then I quickly knew that this table belongs to k. I only have to find the value of c. One is an easy number, so k of 1 is equal to c over 1. And according to the table, k of 1 is equal to 32. Then c is equal to 32, because 32 divided by 1 is 32. Then this table belongs to k, and the value of c is 32. Finally, the last table belongs to the last function that has no table yet, which is h of x. h of x, indirectly, I can say this is the value, but I have to find c. If I put 1 in place of h of 1 is equal to c, absolute value 1, that's equal to c. This is telling me the table that has the value of h, c is 3. Now let me test this 3 to see if it works. If I put 4 in place of x in the function h of 4 is equal to 3, which is c, 3, 4. Absolute value of 4 is 4. Square root of 4 is 2. 2 times 3, 6. Result is 6, then it's correct. Now I find all the tables. I found all the values of c. For this case, c is 3. And this is it. Thank you so much for watching. This is the end of this class. Stay tuned to see the rest of the book.
گروپی لاس بۆ فۆتۆکۆپی و پەراوگا لە خزمەتی قوتابیانی خۆشەویستدایە. بۆ ئەوەی لە وەرزی نوێی خوێندن ماندوو نەبن، ئێمە هەموو پێداویستەکانی قوتابخانەمان بۆ بەردەست کردوون بە بەرزترین کوالێتی و باشترین